So in 2008, when you plug in t equal to 2008, 2008 minus 2008 is what? 0. That is initial. So you see 1.011 to the power 0 is what? 1. 1 times 304 is what? 304. Means what? In 2008, my population is 304 million, right? So let me tell you how they develop this kind of model. Okay, we know the population is growing exponentially. So the population at time t equals to, all right, if I want to say this is 2008, so in 2008 we have 304 million people. Because the growth is exponential, so I wish to put something so that in 2008, I will get this number. So of course, you are going to have 2008, okay, as the standard, as the initial. This is your initial year. Okay? So 2009, what about 2009? You are going to have 2009 minus 2008. So you get e to the power 1. So it shows very clearly, like every year, you are going to develop, you are going to have, what is the growth? E. What is E? E is about 2.7. Okay? So it means every year, you are going to have more than double of the population. So 304 million in 2008. Now in 2009, it's going to be 304 million times e to the power 1, right? In 2008, this is year, this is population, okay? You have 304 million people, right? In 2009, you are going to have this times e to the power 1. In 2010, you are going to have 304 million people times e squared. Do you see what I'm saying? So, oh, this is just this is from where? This is from the government. This is from the U.S. Census Bureau. Okay? This is just approximation. Where did I get e from? Here. Oh, they didn't give you e for this problem, huh? They give you what? 1.11. Okay, so for this problem, for the population, 1.0 what? 11. Okay, I'm sorry. I didn't see that it will be. So they are all in million, right? Okay. Okay. Now here it's going to 1.011. This is 1.011 square. Okay? So they use t minus the initial year in the exponent so that you know at that initial year, this is the population. And we want to know when it's going to become, what? 321 million. So that means I would like to solve 321 million equals 304 million times 1.011 to the power t minus 2008. I want to solve for this t. So this is what I want to solve. How to solve it? Well, remember, this is what? Something times this, right? So I can divide both sides by 304.
Where do we round it to?
Okay? And then I will have 1.011 to the power t minus 2008 equals to, now this is 1.055. I like it. Now, this is an exponential. Remember, we always want to isolate this exponential part. Now you take log with the base 10 or log with the base e on both sides, then you can solve for t. Okay? So I take this. Okay, yes, question?
Where does the t go?
Where's the t? T here.
On the left-hand side, it says p and then in parentheses there's t, but you only put 321, you didn't put the t. Where did the t go?
No, No, you want P of T equal to this means what the meaning of this? This means the population at year T. Like in year, if I say in year 2010, then I put 2000 P of 2010. So if I put 2010 here, that means the population in year 2010. This is a general formula, so this is in.
It's actually 5, 6. I just grabbed it off my head.
5, 6. Thank you. Okay, so this is what? ln, and you know when you do that, this can come down, right? I will do that later. T minus 2008. So now this could come into the coefficient. So you can solve it, right? All right. Is that okay? Actually, every problem is like this. Okay? Can I finish that problem? Sure, I can finish that problem. Can you see? Okay. So what do I have? We have 8.5. The population problem, 65. It says population in the year T equals to 304 million times 1.011 to the T minus 2008. And I want to know when the population will be 321 million. So I want to solve this. Okay, this is what we want to solve. So to do this, we first divide both sides by 304, right? Okay, and you get 1.056 approximately, right? This is approximation. So you get 1.011 T to the power T minus 2008. To solve this exponential equation, okay, we would like to what? Take log on both sides. So I take the natural log. Can I take the log with the base 10? Yes. Okay, you will get the same answer. Now this exponent, remember, this exponent as a whole can come to the front, so you need to put the parentheses. T minus 2008, parentheses, times log 1.011. Okay? Very good. So now, remember, this is a product. So this is a number, so can I divide both sides by that number?
Yeah.
Yes. So when I do that, I'm going to have log 1.056 over log 1.011. I want T, so how do I do? I just add 2008 on both sides, yeah? So T equals to 2008 plus natural log 1.056 over natural log 1.011. Does it make sense? Okay. What is that approximation? Tell me what is that approximation.
4.98.
So T equals to 4. No. How could that be 4? You mean this is 4?
Yeah, that.
Okay. So adding that, it will be what? 2. Okay. It will be 2008 plus 4 point what? 98. So T is approximately, well, we are talking about which year, so you need to round up, right?
Yeah.
So it will be 2013. Is that okay? So in 2013, okay, the population will reach 321 millions. Okay? So I want to tell you, actually 8.5 probably is the easiest type of word problem because they always have to tell us what is the model. Okay? And most of the time, the model is exponential growth. Then you just need to make use of the log, take log of both sides, and solve it. Okay? Any more?
Yes.
Which is?
75.
75 for?
8.5.
8.5. Okay, let's do that. 75. Okay, 75, that's a great question. What is the 75 says? This is talking about study, okay? It says, suppose that a student has 200 vocabulary words to learn. If a student learns 20 words in 30 minutes, 20 words in 30 minutes, pretty fast. The function will be this, okay? The function will be that. Well, 20, 30, 200, you know what? I don't care because I have been given this model. I don't know how they come up with this, but I know this is the model. Does it make sense? So you're given the model already. You are given the model already. Okay? Let's look at this model. Let's look at this model. What does it mean here? Okay? 200. You start with 200. You start with 200. Times 1 minus e to the power negative something t. Okay? Altogether, it says that we would like to learn how many vocabulary? 200. 200. Did you see there's a negative power there? So actually, let me write it down. The model is the learning words at time t equals to 200 times 1 minus e to the power negative 0.0035t. Okay? This is my model. Okay? It shows the number of words L that the student will learn at time t. So what does it mean? This means the number of words students will learn at time t. Okay? Well, you're given a model. That's all you need. The other number information is actually not really changed much. Okay? Because they already take those into account. That's why they developed this model. Does it make sense? So you don't need to worry about those. Maybe those numbers, bothers you. Okay? Thank you. What do we want to find? It says, after how long will the student learn 50 words? After how long will the student learn 150 words? So actually, the problem is so easy. It just says, at what time? At what time? Okay? The L of t will equal to 50. So what does it mean? You want to solve L of t equals to 50 for t. That's what it means. I will ask you what is the t will make LT goes to 50? So you want to solve LT equals to 50 for t. That's all it says. LT is a function, right? LT is a model. LT describes the number of words you learn at time t. Does it make sense? And what is that model? Different school will have different model. Different strategy will have different model. For this learning center, they have this LT. For the other learning center, maybe they have different LT. Does it make sense? But I would like to find out when t equals to what? LT will equal to 50. Does it make sense?
Yes.
Do you know what I'm saying?
Yes.
No. I think that it's because of this. Okay, for example, let me show you another model, then you probably will know. Okay, say we are going to rent a van. Okay, so the rental of a van is what? You start with how many? How much do you think that you need to pay for rent a van? Just to rent it. 150. Okay, I take it. Regardless, you probably just rent a van and let it sit in your garage. You still need to pay 150, right? For 1 day. Okay. But then it will say, well, just to rent it, you need to pay 150 for 1 day. But then every mile that you drive, they're going to count how many miles that you drive. Every mile you drive, you have to pay, say, how much you're going to charge them for 1 mile? That 50 cents. Okay. So and I'm going to drive X miles, right? So every mile that I drive, I need to pay the company $0.5, and I drive X miles. Does it make sense? So this is the total. That's the charge. Okay? The rental of a van this is like overhead. Okay? 150. And then plus that. Now, I only have $200 in my pocket. I rent this van. How far I can drive? Do you know what I'm saying? Yeah. So I'm asking, how far or how many miles can John drive if he only has $200? Then what do you say? You're saying, oh, my rental or his rental is $200. I need to solve this function. This is a function for finding. This is a function. This is a rental function, right? This is like a function of x. Okay, it's telling you what is the charge to rent a van. So I want to find out when the function will equal to 200. So I want to solve this equation for x. Does it make sense? I want to solve this. Now comes Zaya. Zaya is so wealthy and he has $500 for this trip. So Zaya said, you know what? I can take you wherever you go, but still I have a limit. So Zaya has $500 to pay for this rental. Can you find out how far he can drive? Then for Zaya, he needs to solve, well, he has $500. So he wonder, what is the miles, x miles? So you want to solve this for x, right? To find out the number of miles that he can drive. Now back to this. This is a model for how many words you can learn in t minutes. Am I correct? Okay, and I said already, this is just a specific learning center. And we want to find out after how many minutes you can learn 50 words. So it means I want to find out when the function will equal to 50. You want to solve this for t. That's what I want to say. This is a function. The function change, right? The longer time that you learn, the more words you will learn. Am I correct? Yeah? Okay? Different time you put into the study, just like you. Different time you put in the study, you will see different score you will earn in your next exam. Okay? Here, it says, that is a model to learn the number of words. I want to find out after how many t minutes you will learn 50 words. So you want to solve this function equal to 50 for t. So what is that? That is 200 times 1 minus e to the negative 0.0035 t. You want to solve this for t. Okay? Well, how do you do that then? Divide both sides by 200. Okay? Divide both sides by 200. So you get 1 minus e to the negative 0.0035 t equals to 1/4. Okay? And then And then what do you do?
And you take the log.
Well, you still not isolate. You need to isolate my exponential factor. So what do? You probably would like to maybe put this term there, put that 1/4 the other side. Do you see what I'm saying? I would like to bring this term. I would like to add e to the 0.0035 t on both sides, so that it kind of like moving this term there and moving 1/4 the other side, so that make the coefficient positive. You see what I'm saying? No, it has nothing to do with exponent. No, nothing to do with exponent. When you do that, you only do the multiplication, right? Okay, so you will have 1 minus 1/4 equals to e to the power negative 0.0035 t. So 3/4 equals to that. Okay? Now, what should I do next? I will take what? Log on both sides. Yeah? Take log on both sides. Great job. Okay? Since ln has a base e, so they are inverse operators, right? So you would just get negative 0.0035 t, right? They are inverse operators. So now you get this. So what is a t? You just need to divide both sides by negative 0.0035. So t equals natural log 3/4 divided by negative 0.0035. So that's your exact answer. Is that okay? Okay?
Wait, so how am I going to build that natural log for the negative 0.0?
How do I do this?
How come there was no, you took out the natural log?
The e and the natural log.
Yeah, the e.
How what?
Why did they cross out?
Yeah, why did they cross that?
Divide out.
Because they're inverse?
I'm not crossing it out. Don't say that if you are my student. They are inverse property of exponential and logarithm. Okay? Okay, so now let's review this. Recall. Remember, log to the base a of a to the power x. What is that? That's inverse property of log, right? What is this? X. Remember we say you take the train to from Los Angeles to San Diego, and then you take the inverse train. You will come back to wherever you start. Okay? All right? So that's the inverse property of logarithm. And then if you have exponential with the base a to the power log to the base a of x, you also get what? X. That is the inverse property of log and exponential, right? Basically, if you have an inverse function, okay, you did that first, and then you take the function f. This is a composition. What do you get? Tell me. You get x, right? Don't forget about this. This is what we learned at the beginning of this logarithmic functions. Okay, you learn what is the inverse function. Okay, and then if you have taken the function first and then you take the inverse, then you will also get x. Okay. The question is, if I take log at the beginning, okay, you want to solve this for t, right?
Divide that 200. Like, okay, I divide that 200, then can I take the log up to the
Okay. Oh, you still want to divide 200 at the beginning? Okay, let's see. You divide 200 at the beginning. So you still get 1 minus e to the power negative 0.0035 t equals to 1/4. Okay? And now you want to take log. All right. What is the base of log you want to take? Log. Log of 1/4 here. Okay. So now this is a log of a difference. What kind of log property you have? You only have two properties. Log of a product and log of what? Quotient. You don't have any property for log of a difference. Sorry, you cannot do any further work from here. You just stop here. You say, I cannot continue. Do any. No way. There's no any property allowing you to go any simpler expression. Okay? You cannot. There's no any property of log for difference. Okay? But you do have log property for product. So if you want to do at the very beginning, you just have to have log of 200 plus log of that equal to this. It's just one more step. But then here, you just cannot do at all. So this is no way, Jose step. Yeah. Okay? You cannot do this. You cannot do this. You cannot do this. You cannot do this. So what you do? You say, uh-oh, maybe I should get rid of 1. So yeah, you can get rid of 1. You can subtract 1. You have negative e to the negative 0.0035t. So minus 1, so you get what? Negative 3/4. Okay? And then you can multiply negative 1 on both sides. Then you get what we had earlier. Okay? Now, this is exponential to a power, so you would like to what? Just take natural log, ln, on both sides. Does it make sense? Okay?
So when there's an e, in other words, you can't use log. You have to
Oh, you can use log. Say that you want to use log. What happened? If you use log with the base 10, right? So what do you have? Yes, you can. You can. You just have to do a little bit more calculation. You can do it. You can still have this come up here, 0.0035 t times now log e is not 1. Log e is a number. ln e is 1, right? But now this is a number. Okay? Now this is the other number, right? What you need to do is, well, you have t, you just need to find out what is your t. Your t will be natural log 10, 3/4. Divide this and divide that, right? Divide negative 0.0035 and divide log e. You just have to do this. You will come up with the same answer.
But log e is 1, right? So you don't.
This, no, ln e is 1. Log with the base 10e is not 1. No, this is not. This is not 1 because the base is 10. Does it make sense? What I need to do is I want you to turn to each other and explain this problem to each other. Can I have you do that right now? Everybody. And then I'm going to assess you. This is going to be your quiz. Okay? This problem. Can you do that with your neighbor about how to do this problem? The learning model. How many minutes in 1 hour?
60.
It's 60 minutes in 1 hour, okay? So let's say it's 75 part B. You are going to solve 150 equals to 200 times 1 minus e to the power negative 0.0035 t, yeah? Okay? And you divide both sides by what? 200, right? So you get 3/4 equals to 1 minus this. And then what do you do? And then what do? You move this term here, move term there. So you get e to the power 0.0035 t equals to 1 minus 3/4. Again, Mina, thank you for asking. The exponent still stay negative, right? Okay, you only the coefficient. Only the coefficient. Okay, so now this is 1/4. I'm going to take log ln function on both sides. Okay, ln 1/4. So what I'm going to get, I'm going to get negative 0.0035 t equals to ln 1/4. So t is ln 1/4 divided by negative 0.0035, and that is approximately 396 minutes. Okay? How do I calculate this into hours and minutes? Well, 1 hour equals to 60 minutes. Am I correct? So 396 minutes, you would have 396 divided by 60, and you are going to get what? 360. You get 36 remainder. Am I correct? Yes or no? Yes. So actually, you know there are 6 hours. Okay? So 396 minutes equals to 6 hours, and the remainder is 36 minutes. Well, some of you say, Dr. Chen, I didn't do like that. I just go all the way division. All right, so this is one way. The second way, people try to convert it to hours. 396 divided by 60. 360. Okay? And then you have 36. I get what? 396 minutes equals to 6.6 hours. And after that person or that student finds that 6.6 hours, he's realized the question actually asks how to find hours and minutes. So he say, well, it's okay. That means I have this 0.6 hours I need to convert, right? So what is 0.6 hours? Well, 0.6 hours equals to 0.6 hours times 1 hour is 60 minutes. That is, we call this is a dimension analysis, okay? How you convert. So 1 hour is 60 minutes. That is the conversion rate. Times 0.6 hours. So you will have what? 36 minutes. So no matter which way you do, you will get that. Does it make sense? Okay. All right. Next. What is the next question you would like to do? 7.5?
Number 91 and 93.
You mean chapter 5?
7.5.
7.5. You're turning the part B. You pass it.
What about if you have it together with part A? Is that, do you just put it in a different paper? Have A and B.
Oh, part A and B. Yeah. You know what, my friend? I want to just quickly take a look. Can I see? Good. Good. You understand? Okay. Do you understand now? Okay. You know what? I probably would like you to have it for review this weekend because you need to review it. Okay? I will just quickly go over that. You got that? Good. You got that?
What's our problems?
You have to write a solution in complete sentences. Complete sentences, okay? You need to conclude in complete sentences, okay? All right, so all of you got it. Now, let's look at the, you say what?
Number on for 7.5, 91 and 93.
91 and 93. Okay, let's see. 91 on 7.5. 7.5. It says, We did that long time ago. We did that in class long time ago. So let's see. We can do it one more time, no problem. It's 7.5, number 91. What does it say? Well, did you read that problem?
Yes.
Yes. There is how long for the fence?
2,000 meters.
The total length. The total fence, the total length of the fence is 2,000 meters, right?
Yeah.
What else we know? There are only how many sides? 3 sides, right, of the farm need to be enclosed. Am I correct? So you can graph it, make a diagram. You see that this is a width, this is a length, this is a width, because the river part, you don't need that, right? What do they want to find? Find what? Find the dimensions. What do you mean dimensions? Which gives the maximum of the area. Is that right? Okay? So you can do a lot of ways. Say, I want to have such a narrow rectangle shape of the farm. This is my width, this is my length, this is my width. Also come up with 2,000 meters. Or I could have something like this kind of farm, right? This is my width, this is my length. Also 2,000 meters for the fence. Which one would give me the largest area? So, what is our goal? Our goal is maximize the area. Am I correct? Okay, so what do we know? We know the total length of the fence is, so what is given is what? The total length of the fence is 2,000. So this plus that is 2,000. So what do you say? W plus L plus W equals to 2,000. You draw this, okay? And of course you will tell people what is W. Let W to be the width of the farm, okay? And then the L is the length. Okay. And you will say, see the figure, right? All right. Now, add together should be 2,000. And what is our goal? Our goal is what? Maximize. Maximize what? Maximize the area. What is area? So I write down A. What is A? A is W times L. Am I correct? But W and L are not strangers, okay? They are related by this. Am I correct? L is the 2,000 minus 2W. Do you see that? So when people ask you, what is the length? You will say, you tell me the width. I will tell you the length, right? If you tell me the width, then I use 2,000 subtract 2 width, it will be my length, right? Are you with me?
Yeah.
So, I can write this area actually as this way. The L could be substituted by 2,000 minus 2W, right? Yes?
Yeah.
So this area actually is a function of W. Does it make sense? So now this is a quadratic function. This is what? Negative 2W squared plus 2,000W. Okay? And I want to find the maximum. Where you can find the maximum. This is a quadratic function facing up or down?
Down.
Down, because you have negative coefficient, right? It's facing down. What is the maximum? The maximum or minimum would happen at the vertex. Thank you. So you just need to find where is the vertex. Am I correct? Where is the vertex? You can use completing the square to find it, right? Or, actually, there is a formula that you can use. Negative b over 2a. Yeah? We already derived that. So if you say, I don't remember that formula, then use the completing the square. Okay? Then you will say it's negative 2. Now I just need to add a good number to make it complete square. Can you tell me what is the number I need to add here to make a complete square? Plus what? 500 square. If I plus it, I need to minus it, right? So that I am balancing everything. All right? So this is what you have. So you have negative 2. And then these three terms is a complete square. Minus 500 square. Okay? Okay, so now you can distribute it. It will become negative 2 times w minus 500 square. And then negative 2 times this. What is 500 times 500? 250,000, right? 250,000 times 2 is what? You tell me. You tell me what is the thing that I need to... This is negative 250,000. So negative times negative, you become positive. So you have positive 500,000, right? Okay? By completing the square. So you say when w equal to 500, you will get the maximum. And the maximum is this, right? Because when w equal to 500, this term is gone. If w not equal to 500, what happened? Then this term will not be gone. This term will be negative. A number plus a negative number will be less. So, of course, will be less than this. This is your maximum. Does it make sense?
Can you use the equation negative b over 2a?
Sure, you can. Yeah. Yeah, that's easier. Yeah, I want to keep showing you that it's not just a formula. You can get from here because, or you can say the maximum. So, all right, let me say. So the maximum of the area is 500,000 square what? Feet? Meters, right? When the width is 500 meter, and then what is the length? The length is what? 2,000 subtract 2w will be what? 1,000 meter, right? So this is how you do by completing a square. Or you can just use, or we can simply use the formula, okay? X equal to negative b over 2a. What is negative b? So look at this. Look at this. Negative b. So negative of 2,000 over 2a. 2 times negative 2. So negative 2,000 divided by negative 4. Is that 500? Yes. So that means the vertex x coordinate is 500. So what about y? F of 500. Then you just substitute 500 into your formula. So it's a negative 2 times 500 square. Okay? Right? Plus 200 times 500. 2,000. So you will get negative 2 times 250,000 plus what? 1 million. Wow. Okay? And that is negative 500,000 plus 1 million. So it will be 500,000. So we get the same answer. Okay? Does it make sense?
That is very long.
No? You either do this, it's not long, or you do that. When you do the completing a square, you get the maximum right away here, and this is where it happened. When you use the formula, you find out where is happening when x equal to 500. But what is the maximum? You just say, let's plug in the x into my area function, then I get that value. Does it make sense? Okay. This has happened to be a problem in the final exam in the previous years. People always ask this kind of question because this is how we make use of the parabola. Okay? Parabola function give us the shape that you know very clearly where you will have the minimum or maximum. Okay? And this is the application. All right. So I think I went over in detail those kind of questions that you would like to investigate more. So
You can answer it before we leave.
sure, which one?
Number 85.
85 of
Oh, yeah. Some numbers such that their product is a mess.
7.5? 85. The sum of 2 is 36. That the product is maximum. That is easy. Okay. Okay, let's do it because I say it's easy, but you don't believe me. Just like I say 8.5 is easy because you are told the model, right? 85. It says what? The sum is what? The sum is? So you put the sum is 36. And then the product is what? The product. You want to have the what? You want to maximize the product. Am I correct? Oh, let me write it again. Okay, the given data is what? The sum is 36. And the goal, what is the goal? We want to maximize x times y. Am I correct? Just like what we did before. What is x times y? You have to know they are not strangers. You have relationship between x and y. X, if you know x, you know y. Okay, let me find out y. What is y? Y is 36 minus x. Am I correct? So x times y is actually x times 36 minus x. So it is negative x squared plus 36x. So this is my function. It's quadratic. So it is with negative coefficient, leading coefficient. So it's what? Facing down. You have maximum. Where? Oh, where? X equal to negative b over 2a. So negative b, negative 36, over 2a, 2 times negative 1. So that is what? 18. The maximum happens when x equal to 18. That's it. So what is the maximum? Okay, the maximum of the product. Okay? So when x equal to 18, what is y? Y is also what? 18. So the maximum of the product is 18 times 18 is 18 squared. Let me tell you, this is a very, very commonly asked question. Somebody give you a rope. They say, find a rectangle that give you the maximum area. Rectangle could be like this, could be like this. What is the rectangle shape give you the maximum area? The square. The square. So this is says, right? The sum is 36. The product is maximum. These two numbers has to be as close as possible. Does it make sense? All right. So I think that you're good. Try to study more, and Tuesday will continue. So you should have all the packet done, no problem. I will put in more problems for you to review from Canvas. Okay? All right. Thank you so much.